You've probably heard the word cement and concrete thrown around as if they're the same thing. But did you know they're as different as flour is from bread? Yep. Just like flour is an essential ingredient in bread making, cement is the glue that binds together concrete. But that's just the tip of the iceberg. Let's dive into the fascinating world of cement and concrete and demystify the entire process from the blasting of raw materials, right down to your neighborhood sidewalk. Imagine the first step in cement production, set in a vast open quarry. Picture the early morning light casting long shadows over heavy machinery and rugged terrain. This is where nature meets technology. The air vibrates with the rumble of explosives, carefully calculated to break the earth and reveal its hidden treasures: limestone, shale, and marl. These aren't mere rocks. They are the ancient remains of sea creatures and plants compressed over millions of years, waiting to be transformed into a key ingredient of modern civilization. In this expansive setting, skilled workers operate with precision. The history of quarrying dates back to ancient Egypt, where limestone was extracted for the pyramids. Fast forward to today, and the methods have evolved dramatically, but the principle remains the same: sourcing the best raw materials for a superior end product. Each blast in the quarry is a meticulously planned event, considering geological surveys and environmental impact assessments. It's a blend of science and art, ensuring the right mix of materials is harvested. Envision a scene of colossal scale and raw power. Massive haul trucks, each with the capacity to carry 60 tons, rumble towards their destination. These mechanical giants, embodying the might of modern engineering, transport raw materials from the quarry to the crusher. The journey, though short in distance, is monumental in the process of cement production. Each truckload contributes to a continuous flow of materials, vital for the unceasing demand of construction industries worldwide. Upon reaching the crusher, a spectacle of mechanical prowess unfolds. The crusher, a cornerstone in the cement-making process, is not just a machine but a symbol of the transformation of natural resources into vital building materials. Here, the raw stones, limestone, shale, and other minerals are subjected to immense pressure, breaking them down to the consistency of rough gravel. This transformation is not merely physical but symbolic, marking the transition from natural resource to a foundational component of construction. Imagine the force exerted by the crusher handling 600 tons per hour. It embodies a relentless and awe-inspiring process. Each crunch and grind of the crusher is a testament to human ingenuity in harnessing nature's bounty for our needs. The crusher's role is pivotal. It ensures the uniformity of particle size, a critical factor in the quality and strength of the final product. This step in the cement production process is a perfect blend of tradition and technology, where the age-old practice of breaking stone meets the precision of modern machinery. At the heart of cement production lies the mixing bay, a monumental structure where the foundation of cement strength is formed. Picture a colossal cylindrical tower, stretching 81 meters across and soaring 28 meters high. This is not just a physical structure, it's the alchemical chamber where diverse materials are transformed into a uniform, consistent mix. In this vast chamber, the rough gravel from the crusher converges with other essential ingredients. Each component has traveled a different path, carrying its unique properties essential for the final product. The mixing bay is where these paths intersect, creating a symphony of elements that will eventually become cement. The process here is a meticulous balancing act, a fusion of science and precision engineering. Operators at the mixing bay are akin to conductors of an orchestra, each movement calculated, each decision critical. They oversee the blending of materials like limestone, clay, and iron ore, ensuring that the chemical composition is just right. The stakes are high. Even a minor deviation in the mix can compromise the quality of the cement. This step is about achieving homogeneity, a consistent blend where each particle is indistinguishable from the next. The technology employed in the mixing bay is a marvel in itself. Advanced sensors and control systems monitor the blend, adjusting the proportions of each ingredient in real time to maintain the perfect balance. This high level of automation ensures that the quality of the cement remains consistent, batch after batch. In the grand narrative of cement production, the raw mill represents a critical transition, a place where the blended materials from the mixing bay undergo a significant transformation. Envision a vast, industrious space where additives like iron ore are introduced to the homogeneous mix. These additives are not mere supplements. They play a pivotal role in imparting specific properties to the cement like color and strength. The raw mill is where the journey of these combined materials takes a turn towards refinement. Here, the mix is ground into an ultra-fine powder, aptly named the raw mix. This process is more than just grinding. It's an alchemic conversion, preparing materials for the intense heat they will soon encounter in the kiln. Picture giant rollers and balls within the mill, tirelessly working to reduce every particle to the desired size. The precision here is paramount. The finer the particles, the more reactive they become, setting the stage for the clinker formation. The transformation in the raw mill is not only physical but also chemical. The heat from the pyro process, a precursor to the extreme temperatures in the kiln, starts to initiate chemical changes in the materials. This heat treatment is a delicate process, requiring exact temperatures to ensure the desired reactions occur. It's a fine balance akin to a chef carefully adjusting the heat to bring out the flavors in a dish. The fine powder now carries within it the potential to become the hard, binding material we know as cement. The raw mill, therefore, is not just a part of the process. It's a crucial link in the chain of cement production, transforming raw, blended materials into a refined product. Ready for the next phase of its journey, the fire of the kiln? The process begins with the preheater, where raw materials are preheated using hot gases from the kiln. This preheating is crucial for energy efficiency. The material then moves to the raw mill silo, a storage space that ensures a continuous and regulated feed into the kiln. Here, a careful balance of the chemical composition is maintained, vital for quality control. As we reach the rotary kiln, the temperature soars to over 1450 degrees Celsius. It's a scorching environment, hotter than lava erupting from a volcano. At this blistering temperature, raw materials undergo a transformation. The calcium carbonate in limestone decomposes into calcium oxide and carbon dioxide. Then, calcium oxide reacts with silica, alumina, and iron oxides to form a new substance: clinker. This clinker is the essence of cement, the base for what will eventually be the concrete in skyscrapers, bridges, and homes. What's truly fascinating is the daily output. This single kiln churns out a staggering 2,100 tons of clinker per day. To put that into perspective, that's roughly the weight of 350 adult elephants produced daily. After the fiery molten clinker, fresh from the kiln's inferno, tumbles into the cooler, here a mechanism akin to an industrial breath of fresh air awaits. The Great Cooler, an ingeniously designed system, employs air quenching, a process vital for both the quality of the cement. The cooling process is not just about temperature reduction. It's a critical phase where the clinker undergoes physical and chemical transformations. As the clinker cools, its crystalline structure changes, directly affecting the final properties of the cement. The next phase, grinding and blending. This stage is where the clinker's potential is unlocked, transformed into the fine powder we recognize as cement, ready to bind and build the modern world. In the heart of the cement manufacturing process lies the laboratory, a cornerstone of quality assurance in the cement industry. Here, amidst an array of sophisticated equipment, a team of skilled technicians and scientists work tirelessly, testing over 140 samples every single day. As we delve into the final stages of cement's journey, here the cement, now a fine powdery substance, is meticulously measured and packed into bags, each precisely weighing 50 kilograms. This precision is crucial as uniformity in packaging ensures consistency in building projects across the globe. For larger industrial-scale customers, bulk cement offers a different logistical dance. This form of cement skips the bagging process entirely. Instead, it is funneled into large silos where it awaits transport. Bulk cement is typically transported in specialized tanker trucks, each equipped with pneumatic systems for easy loading and unloading. So the next time you walk on a sidewalk or admire a skyscraper, remember it's not just cement you're seeing. It's a complex, carefully crafted blend of materials that has been perfected over time, from raw limestone to the finished concrete that shapes our world. What's your favorite part of this rock-solid process? Let us know in the comments below. Are you ready to explore more? Don't forget to check out our other videos to keep the curiosity rolling.